A great day to all. In this video lecture, let me discuss about the carbonization of coal. Carbonization of coal, otherwise called as coking process. When coal is heated to a high temperature in the absence of air, it is converted into lustrous, dense, porous and coherent mass known as coke. The process is referred to as carbonization. Caking and coking coals. When coals are heated strongly, the mass becomes soft, plastic and fuses to give a coherent mass. Such type of coals are called caking coals. If the mass produced is hard, porous and strong, then the coals are called coking coal. Coking coals possess lower volatile matter and are used for the manufacture of metallurgical coke. Metallurgical coke. A coke which is used in metallurgical purposes is called as metallurgical coke. These should be hard, strong and porous in nature. Requisites of a metallurgical coke. It should possess minimum percentage of moisture, ash, sulfur and phosphorus. It should possess high calorific value, high mechanical strength and it should resist abrasion and should be chemically inert. Coke should be uniform in size and high porosity. Coke should burn easily. Classification of coke ovens. There are two types which includes byproduct coke ovens and non-recovery coke ovens. The byproduct coke ovens include the volatile byproducts are collected for subsequent use. And in non-recovery coke ovens, no recovery of byproducts. Non-recovery coke ovens, beehive oven. The simplest type of coke oven consists of an almost enclosed brick-kiln known as beehive oven. The coal to be cooked is spread across the floor of the oven and the top of this bed ignited just before the door to the oven is sealed. Heat from the combustion of this top layer dries off the volatile matter from the rest of the coal and combustion of the volatile provides further heat for the cooking process. Excess volatile matter is discharged through a chimney at the top of the oven and usually burned off as waste. When the process is complete and all of the coal has been carbonized, it is allowed to cool, the door is opened and the coke is removed. A beehive oven is a type of oven used since the Middle Ages in Europe, used for cooking and baking important foods like breads. Beehive oven also had industrial uses. Large ovens were heated and used to turn coal to coke and in iron making. Otto Hoffmann's byproduct oven. In order to increase the thermal efficiency and recover valuable byproducts like coal gas, ammonia, benzol oil, tar, etc., Otto Hoffmann developed a modern byproduct coke oven. Here heating is done on the basis of a regenerative system of heat economy. The construction of Otto Hoffmann's byproduct oven includes. It consists of a number of narrow silica chambers, each about 10 to 12 meter long, 3 to 4 meter tall, and zero point 0.4 to 0.45 meter wide, erected side by side. Each chamber has a door at the top to introduce the coal, a gas offtake valve, and a refractory lined cast iron door at each end for the coke to discharge. The ovens are charged from the top and closed to restrict the entry of air. Working of Otto Hoffmann's byproduct oven. Coal is charged into the chambers and the doors are closed. The chambers are heated by burning mixture of preheated air and producer gas at 1200 degrees Celsius. The few gases produced during combustion exchanges their sensible heat before leaving the chamber and the temperature is raised to about 1000 degrees Celsius. Heating of the oven is continued till the liberation of volatile gases. After 11 to 18 hours, the coke discharged from the oven may be quenched in two ways, viz. dry quenching and wet quenching. In dry quenching, coke is allowed to cool in air. In wet quenching, it is sprinkled and quenched. The yield of coke is about 75%. Recovery of byproducts. The gas coming out from the oven has many valuable byproducts which are recovered in the following recovery units. Tar. The gases enter the first unit where the heavier tar fractions are separated by spraying liquid ammonia. Even the traces of tar are removed by passing through electrostatic precipitator. Ammonia. The tar-free gas is bubbled through sulfuric acid or water. Ammonia gets converted into ammonium hydroxide or ammonium sulfate as crystals. Naphthalene. The gases then pass through a tower in which cool water is sprayed. Naphthalene is condensed at this stage. Benzene. In the next tower, where petroleum is sprayed, benzene gets condensed into liquid. Hydrogen sulfide. The remaining gases are then passed through a purifier packed with moist iron oxide. Here, hydrogen sulfide is retained. Significance. This method increases the thermal efficiency of the carbonization process by using the sensible heat of the flue gas. Recovery of valuable byproducts from coke oven gas. Thank you for watching this video lecture.